My name is Bidar Babu from the branch AC section. My roll number is 244G1A0587 and the subject name is chemistry. Subject code is 23CHG01 and the topic is separation of liquid mixtures, and we are discussing about the separation of liquid mixtures, how to separate the liquid mixtures into different components. Now we have to see first introduction to liquid mixtures. Liquid mixtures consist of two or more liquids that are combined but not chemically bonded. They can be homogeneous, where components are evenly distributed, or heterogeneous, where distant layers are visible. Understanding how to these mixtures is crucial in various industrial and laboratory applications. Importance of separation techniques. The separation of liquid mixture is essential for purifying substance for chemical reactions and processes. It allows for the recovery of valuable resources and the disposal of waste products. Effective separation techniques can enhance the efficiency and sustainability of manufacturing process. We can see in the figure separation of mixtures by different processes, for example hand picking, distillation, etc. Distillation process. Distillation is a widely used method based on differentiating in boiling points of the components. The mixture is heated until the component with the lower boiling point vaporized, then it is condensed back into a liquid by the condensation process. This technique is commonly used in the production of spirits, petroleum, refining and chemical substance. Now we can see the distillation process in the whole diagram. And the next one is fractional distillation. Fractional distillation is an advanced form of distillation that separates components with closer boiling points. It employs a fracturing column to provide multiple vaporization and condensation steps. This step is particularly used in separating complex mixtures like crude oil into its various components. We can see in the figure fractional distillation of the crude oil into different products for used for the different purposes based upon the boiling points. And the another liquid extraction is a separation. Liquid extraction involves the transferring a solute from one liquid phase to another based on solubility difference. This method is often used in the paracetamol and chemical industries to solidate specific compounds. It is advantageous for separating component when distillation is not feasible due to similar boiling points. And the next process, centrifugation separates liquid mixtures by utilizing the centrifugal force generated by rapid spinning. Denser components migrate outwards from distant layers, which can then be collected separately. This technique is commonly applied in biotechnology and laboratories to separate blood components and or cellular mixture. Centrifugation process is shown in the diagram. Membrane filtration is also nowadays used in a widely range. Membrane filtration employs semi-permeable membranes to separate components based on size or shape. This technique is effective for purifying liquids and removing suspended solids, bacteria and other impurities. It is widely used in water treatment, food processing and biotechnology applications. Now you can see in the figure how the membrane filtration is fixed in the industry. And now we are knowing about the absorption techniques. Adsorption involves the addition of molecules from a liquid mixture on the surface of a solid absorbent. This method is beneficial for removing impurities and recovering valuable substance from liquid mixtures. Common applications include wastewater treatment and extraction of specific components from natural resources. In the diagram we can show absorption was absorption. There is a major difference between absorption and adsorption. Challenges in separation. Many of the challenges faced by this separation in the separation of liquid mixtures. Separation of liquid mixture can be complicated by the presence of azeotrope which behave as a single substance. The efficiency of separation techniques can be affected by temperature, pressure and the nature of the components. Continuous research and development are needed to improve existing methods and develop new ones. Now we can clearly show as azeotropes as in the figure. Conclusion and future direction of separation of liquid mixtures. Mastering the separation of liquid mixtures is vital for advancements in chemistry and industrial processes. Ongoing innovations such as green chemistry approaches and nanotechnology show promise for more efficient separation methods. Future research will focus on sustainable particles and development of new materials for separation of separation techniques. We can show the different separation technique as shown in the figure. Thank you for this great opportunity.